In today's video, we will be looking at the finite element analysis of heat transfer in the fin. The topics are as follows. First is the introduction, followed by problem definition. Then we will look at the conventional methods to solve the problem using the heat transfer approach. Then we will look at the FEA method applied to the problem. And finally, we will look at the Ansys steady state thermal analysis and compare the results. The rate of heat transfer by convection from the surface maintained at temperature T's and the surrounding temperature T infinity is given by Newton's law of cooling. Since the surface temperature and surrounding temperature remain constant, there are only two options to increase the heat transfer rate. First is to increase heat transfer coefficient H. Increasing H may require the installation of a pump or fan or replacing the existing one with a larger one. But this approach may or may not be practical. Besides, it may not be adequate. The second approach is to increase the surface area by attaching the extended surfaces called fins. This method is quite common in most applications. Sometimes we can apply both approaches to enhance the heat transfer rate. The problem definition is as follows: an aluminum alloy with a thermal conductivity of 200 watts per meter kelvins with a cross section of 10 by 3.5 millimeter and a length of 25 millimeter. It protrudes from a wall. The base is maintained at 420 degrees centigrade, and the heat transfer coefficient may be taken as 11 watts per meter square, kelvins. Find heat loss and temperature at 10 millimeters from the base if the heat loss from the tip of the fin is negligible. Take the surrounding temperature as 30 degrees centigrade. Analytical approach to solving the problem is shown. The detailed derivation of the method can be found in the given references. The FEA method and the governing equation for fins are given by using the weighted residual method. The elemental matrix can be obtained. We divided the domain into two elements as we needed to find the temperature in between the lengths. And then we write the elemental matrix for each element. After the elemental matrix, we assemble the global matrix by combining the elemental matrix. And then the boundary conditions are imposed, which are the surface temperature and the insulated tip. By solving the equation, we obtain the variable theta and find out the temperature at the node. The variable is substituted in the equation to find the average heat flow. Now we'll look at the Ansys Workbench for the simulation. First, drag and drop the steady state thermal into the workbench. Go to engineering data and edit the material properties, in this case, the thermal conductivity of the material. Note that in this case, the name of the material is not changed, which does not affect the analysis, but it is preferable to change the name. Go to Design Modeler, change the unit, and draw the cross section of the fin as per the dimensions. Select the sketch and extrude the cross section as per the length of the fin by giving the depth and change the operation to add frozen. And since we want to find the temperature in between, we need to slice the body, select the plane, and make a new plane with an offset. Select the slice option and select the newly created plane and body to be sliced. Click on Generate, So form a new part and set the share topology option. And now we will go to Ansys Mechanical. So go to Geometry and check the material assignment for both bodies. Generate the default mesh. Apply the boundary condition as surface temperature by inserting temperature and selecting the face. Insert convection and select all the faces of the perimeter by holding the control button. Remember to change the unit according to the problem. Otherwise, the result may alter, and also check the unit of the heat transfer coefficient. Enter the data as per the problem. Fin is insulated at the tip, therefore, insert heat flow and selecting the face. Choose the perfectly insulated option. Click on Solve. After solving, go to Solution, right-click, Insert Temperature, and select the interfacing face by selecting. Similarly, insert the temperature and select the face of the tip. For finding the heat flux, insert the total heat flux and select the face at which the surface temperature is applied. Note the average values for temperature and heat flux. To find total heat, multiply the average heat flux by the cross-section area to obtain the average heat transfer. Another method to find out the total heat flow, insert probe and select reaction at temperature. Evaluated the result. This gives the total heat transfer through the base of the fan. Save the project. The result is tabulated as shown. The results of the FEA Matrix method and ANSYS are matching the analytical method with good accuracy. The error in the temperature is very low, but the heat transfer queue has an error that is within the limit. The following are the references that you can use for further reading. Did you think about this? During the study of conduction in slab, we use T temperature, while in study of fins, we use data. That's all for today's video. Thank you.